All right, we are starting a new unit on page 57, so you should be turned to page 57 for this new unit. This is our final unit of the year, and we're going to talk about energy, both types and transfer of energy. Energy is the capacity of something to do work or transfer heat, the ability for something to do work or transfer heat. The total amount of energy always remains the same. Energy can come in two main forms. It can be kinetic, which is energy due to an object's motion. For instance, thermal energy, like heat. It determines how active the atoms are, how much they're moving on an atomic level, how much the electrons are moving, how much the protons and neutrons are moving, how much the atoms are moving in relationship to other atoms they're bonded with, or sitting around, and so on and so forth, vibrating, all of that. You can also have electrical energy. Anytime you have a movement of charged particles like electrons, you have electricity, and that's a type of energy. And then there's a type of electromagnetic energy that we're just going to sum up as light energy, which we talked about way back in Unit 4. You also have potential energy, which is energy based on position. You have some subtypes of potential energy as well. We mostly worry in chemistry about chemical potential energy, which is from chemical reactions or bonds. It's stored within a substance. But there's also gravitational potential energy. That's the one you're going to talk about in physics a lot, from an object's height and mass. The energy stored in an object based on how high up it is and how much it weighs. The law of conservation of energy says that energy cannot be created or destroyed during a chemical and physical process, but it can be transferred. One form of energy can be converted to another. Here are some examples. A power outlet is used to turn on an electric fan. And then it says, as something energy is converted to something energy, does the total amount of energy change? Well, the power outlet is going to have electrical energy in it. And an electric fan, that's like one of these things. I'm not a great artist, y'all, but then it's got like those blades inside. You know what I'm talking about? Okay, and then the blades move in a circle. That's going to be kinetic energy, just general motion. As electrical energy from the outlet is converted to kinetic energy in the fan, does the total amount of energy change? No. The total amount of energy will always remain the same. When gasoline is burned to move your car, gasoline has stored energy in the bonds. The way that works is you burn the gasoline and the energy in the bonds gets released to power your car. So that's chemical potential energy. We can just call that chemical energy. And then again, moving our car, that's going to be generic kinetic energy. As that happens, does the total amount of energy change? No, never. When you turn on an electric lamp, you're starting with electrical energy. And then the lamp is going to have light energy. Does the total amount of energy change? No, never. You may be noticing a pattern here. Number 4, this time, gasoline in your car is used to turn on your headlights. You start again with gasoline powering your car, and then you're able to power your headlights as your car is turned on. Again, the gasoline has chemical energy stored in it, and this time your headlights are light energy. As that change happens, does the amount of energy change? No, you have the same amount of energy as before. Total. A tomato plant uses the process of photosynthesis to turn into a tasty tomato for your salad. Photosynthesis, remember, uses light energy, and then the light becomes fuel for the plant, and it grows a tomato from that, and there's fuel stored in the tomato. Again, stored energy in the bonds of the tomato, that's going to be chemical energy. As that happens, does the total amount of energy change? No, never. Let's turn the page. Thermochemistry is a study of the heat change that occurs during chemical reactions. Remember, we've talked about this before. Temperature is the measure of how much average kinetic energy the particles have. That's a measure of movement. Heat and temperature are not the same thing. I've mentioned this before, and now I'm going to tell you what heat really is. Heat is energy that transfers from one object to another because of a temperature difference between them. So it is related to temperature, but basically the temperature difference would be a difference in motion. So if one of them has atoms that are moving more than the other, that kinetic energy at a molecular level can get transferred in the form of heat. Heat will always flow from a warmer object to a cooler object. So something that's moving more will transfer its motion to something that's moving less, and it always moves in that direction. Note also that our variable for heat is a lowercase q. We're going to come back to that in a bit when we do some math, that the q is going to be the variable we use for heat. Why q? I honestly do not know. You could Google it if you want to, but it's not h. H is something else because, you know, why not? Okay, the universe is divided into two halves. You have your system, you have your surroundings, and all of that together is the universe. So the system would be the thing that you're studying. It's your substance of interest, the thing you're actually studying. The surroundings are pretty much literally everything else in the universe, whatever is outside the system. So if this part that I'm studying, the chemical, is my system, the surroundings are everything else in the whole universe. Outside the system, that's the surroundings. Energy, or heat, can be absorbed or released. You have exothermic situations and endothermic situations. When you have an exothermic situation, what does this prefix exo make you think of? Perhaps the word exit. Okay, exo means out of. So energy is released. It's moving out of the system when it's exothermic. So the Q, the heat, will be negative because you are losing the energy. It's leaving the system. The system is losing heat. The surroundings are what's gaining heat. For example, liquid water changing to ice. The liquid water has to get colder to turn into ice, so it's going to lose heat. And that heat is getting released as a product. That is an exothermic situation. Endothermic is when energy is absorbed. Again, if you think about that prefix endo, that means into. Endo means into, so energy is going in. The heat, the Q, will be positive because the system is gaining heat. The surroundings are losing heat. The system is gaining heat. For example, if you start with solid water, so ice, you have to add heat energy to get it to change into a liquid. The water has to gain energy to change into a liquid. We have some pictures down here of some things, but I want to call your attention to some specifics here. Remember, again, exothermic is negative because the system is losing heat. Okay, endothermic is going to be positive because the system is gaining heat. Those are some important distinctions to make sure that you know. And then we can look at these pictures. Obviously, you'll be able to see it better on your own page than you will on my video, but I'll zoom in on a couple of them too. This one, exothermic versus endothermic, notice that for endothermic, the heat's going into the system from the surroundings. Transferred from surroundings to the system, the surroundings get cooler. That means it would feels cold when you touch it. Endothermic feels cold when you touch it because the surroundings are getting cooler. The system is stealing heat from the surroundings, and guess what? You are the surroundings. You're not the system. Chemistry doesn't study you. That's biology. Chemistry is studying these chemical systems. So if it feels cold to you, well, you're the surroundings. If it feels cold to you, it's taking your heat. The heat is getting transferred from you to the system, and it's going into the system. For exothermic, the system's leaving. Heat is transferred from the system to the surroundings, so energy is leaving the system. The surroundings get warmer. Again, that means it's going to feel warm when you touch it. And that's because the heat is leaving the system and coming out to where you are, and you are part of the surroundings. Another really important thing to notice here, it says add energy on top, so this is endothermic. Endothermic processes include melting and evaporation. I will expect you to know that. That is going to come up on a quiz. Being able to look at something like melting or like evaporation and tell me is that endo or exothermic. Endothermic is going to be melting and evaporation. Removing energy, so exothermic, that's going to be things like freezing and condensation. I can 100% guarantee you that will come up on a quiz and on your test, so make sure you know the difference. You can also look at these two graphs down here of endothermic and exothermic reactions. In an exothermic reaction, the heat is released, so Q is negative, and you can see the reactants have more energy than the products, and this amount of energy right here, that is the negative released Q, heat. In an endothermic reaction, the reactions start off with some amount of energy, and then they gain energy, heat is absorbed, so Q is positive to make your products. The products have more energy than the reactants. In this picture, we're going to write if the system or the surroundings is increasing or decreasing in temperature. When you have a hot cup of coffee, heat is leaving that system. So the system, the coffee, is experiencing a decrease in temperature. The surroundings are experiencing an increase in temperature. If the system is losing heat and the surroundings are gaining heat, when the system loses heat, that is exothermic. Here you have a cold cola, can of soda from the fridge, and heat is going into the can, so the system, the soda, is increasing in heat while the surroundings are losing their heat. The soda's taking it from the surroundings, so they are losing their heat. When the system gains heat, that's going to be endothermic. But if you think about it, the cup of coffee is going to feel hot to you. While the can of soda feels cold to you. Okay, so there's some practice down here for system and surroundings. And I expect you to do this practice yourself. You need to do this practice yourself. It will be part of a stamp, just so you know. You have to do this practice yourself. I'm going to move on and turn the page as far as this video goes. But this is going to be part of a stamp. You do have to do that yourself. Oh, actually, that's where I'm going to end this video. I'll do the math in a separate video. So here you go. Work on this. This is going to be part of a stamp. Finish this chart right now.